Hey everyone, in this video let us talk about dairy products. Okay, so dairy products are nothing but milk and its products. So all kinds of milk products are called as dairy products. So what are the milk products that you know? It can be butter, right? Cheese and ghee. So any kind of milk product, it can be buttermilk, yogurt, right, curd. So whatever the milk products you have, all of them are called as dairy products. So let us discuss about the composition of milk as well as the composition of all these products one by one. So coming to the first concept, composition of milk. So here what actually we mean by milk? Milk is an emulsion of fat in water. Okay, so it is a emulsion. So emulsion is a kind of solution, guys. Okay, so emulsion is not a normal solution. Emulsion is a kind of solution where the fat molecules are quite big. So these fat molecules dissolved. So they are dissolved in water. Okay, so in water along with proteins, minerals, carbohydrates and etc. Okay, so I repeat once again, what is milk? Milk is an emulsion of fat molecules which are dissolved in water along with proteins present in a milk, along with carbohydrates and all other minerals. Okay, so it's very important to remember, milk is an emulsion of what? It is an emulsion. Emulsion is a kind of a special solution. Okay, it's a special kind of colloidal solution and it is a fat molecule dissolved in water is called emulsion. Okay, yes. So what other things you have in milk? So along with fat in water, you have proteins, you have carbohydrate called lactose, you have minerals and you also have vitamins. Okay, so if you look at the different components in different ratio, water is highest in milk, 86 to 88% is water, minerals are about 0.7 to 0.8%, fat is about 3.5 to 4.5% and protein is of 3.2 to 3.5, lactose is of 4.8 to 5.0. So these are the different percentages of the different components present in a milk. So now let us discuss about each component, how it is present in milk and what is the use of that component. Okay, so let us discuss about the very first component, protein. So we keep on hearing these words like milk is a good source of protein, right? So yes, milk is a good source of protein and you have different types of protein. What kind of proteins are there in milk? Number one, there is a protein called casein and there is a protein called whey protein. Okay, so these are the two types of proteins that you will find in milk. Okay, so guys, one is casein. So 80% of the protein is casein and 20% is the whey protein. Okay, so this casein exists in the form of micelle. Okay, and it is rich in calcium, phosphorus and precipitates when milk is acidified. Okay, so this particular protein gets precipitated when milk is acidified, right? So anyway, even if you don't remember all of this, just remember that there are two kinds of protein that are present in milk. Number one, casein, and number two is a whey protein. Okay, so this whey protein and the casein are easily digestible protein, right? So very safe protein that is present in milk actually. So this is all about the protein content that is there in a milk. So now coming to, yes, what are the functions of protein? We all know proteins will help us in building muscle, they help us in improving immunity, they help us in repairing the cell. For cell growth, protein is very much essential. Okay, so that is the uses. These are the uses of protein that is present in milk actually. So next category, I mean the first component is over. We discussed about protein. So the next component of milk is the carbohydrate. So you know carbohydrates are different types. You have monosaccharides, disaccharides and polysaccharides. The type of carbohydrate that is present in milk is lactose. So remember what kind of carbohydrate is present in milk? It is lactose, which is an example of disaccharide. Okay, lactose is what type of carbohydrate? Lactose is a disaccharide. Okay, so you no need to know all the story about carbohydrate. Just understand what kind of protein is there. Lactose, which is a disaccharide that is present in milk. And what is the importance of carbohydrate? It gives energy, it helps in brain function, it helps in digestion, it will also help in preventing protein as a source of energy. Okay, right? So just if you want to know two importances, just get to know that carbohydrates are good source of energy and they help in functioning the brain properly. Okay, so this is about the second component of milk. So now moving ahead to the third component. Yes, what is the important third component that is also present in milk? That is fat. Okay, so milk fat exists as small globules. So they are present as small globules in the sense a kind of bubbles. Okay, yes, so we all know fat is nothing but chemically it is a triglyceride. Okay, so fats are nothing but triglycerides. Okay, so just understand, you know fats are concentrated sources of energy supplying 9 kilocalorie per gram. So remember how many calories the fats will produce? It's almost up to 9 kilocalories per gram. Okay, so the fat content also is there in a milk. Yes, so that is all about the fat that you should know. And the next component is the minerals and vitamins. So what are the minerals and vitamins you will observe in milk? So you can observe. What do you mean by minerals? It is elements. Okay, so milk has got calcium, it has got phosphorus, it has got magnesium, potassium and zinc. Okay, so what does the use of calcium? Calcium helps in giving bone and teeth strength. Okay, and phosphorus will help in the metabolism of energy. Magnesium, potassium and zinc. So all of these are different minerals present in milk. And then what are the vitamins present in milk? Vitamin A, vitamin D, B2, B12 and E. All these vitamins are present. Okay, so these are the major components of milk, guys. So let me revise all the components. Okay, so now what is milk? Milk is an emulsion of fat molecules dissolved in water. So number one component, protein. What are the two types of protein you will observe in milk? Casein and whey protein. So number two component, carbohydrate. Which is the carbohydrate present in milk? Lactose. Number three, fat is there in milk. Number four, what is the component? Minerals and vitamins. What are the minerals present? These are the minerals present. What are the vitamins present? These are the vitamins present. So this is all about the composition of milk. Okay, so now let us go for composition of other milk products. Okay, so composition of milk products. What do you mean by milk products? As I told you, butter, ghee, okay, so cheese, all these are milk products, isn't it? So some of the milk products composition we have to study. So composition of milk products, under that the first one, let us understand about butter. What does the butter contain? So what is a butter in fact? Butter is a water in fat emulsion. Okay, so butter is solid, yes or no? So the moment you talk about butter, it is solid. So you will have liquid in solid. Okay, so liquid in solid type of emulsion. So butter is liquid in solid type of emulsion. Okay, so you will have little amount of water. What is the liquid present in butter? That is water. Water present in fat. Okay, so it is an emulsion of water in fat. This is very important. It is an emulsion of water in fat. Little amount of water present in the large amount of fat. That's what we mean by emulsion here. Water in fat emulsion. So coming to the composition. So what is the composition? What does the butter contains? Butter contains milk fat. It contains water and milk solids, and it also contains vitamins. And here you can see what is the percentage level that milk fat is present, water and milk solids are present, and vitamin A and vitamin D are present in butter majorly. Okay, so now coming to the uses of butter, and these are the key features. That means butter is solid at room temperature. Okay, so it is very rich in flavor, and it is a high energy containing food. Okay, so what is butter used for? Butter can be used in cooking, baking. It can be used as a flavoring agent. It can be used as a good source of protein, also good source of energy also. You know, all these are different uses of butter. So here what is important is just remember about the composition. That's it. Okay, yes. So now coming to the next milk product, that is cream, right? So cream is that fat. It is that fat separated from milk. It is the fat separated from milk is called as cream, isn't it? So cream is the high fat layer skimmed, that is separated from top of milk before homogenization. Okay, so before it gets turned out homogeneously, you know, that high fat layer which gets separated from milk, that high fat layer is called as cream. Okay, and now you know, you have different types of creams actually: light cream, heavy cream, and whipping cream. So this is the fat content present in light cream. The fat content is 18 to 30%. Heavy cream, it is more than 36%, and in whipping cream it is 30 to 36%. Okay, so that is the fat content. So the cream has got only the fat content. It does not have any other component in fact. Okay, so now coming to the next milk product, that is cheese. Okay, right? Cheese is a concentrated dairy product formed by coagulation of milk protein. You know, the paneer is in the Indian version. Okay, so the paneer that we use is also equivalent to cheese only. So in milk, when you put a lemon, when you squeeze a lemon, you know, all the fat will get solidified, right? That's how the paneer is made. So cheese is equivalent to paneer in the Indian version, guys. Okay, so if you look at the composition of cheese, you can see protein is there in cheese, fat is there, minerals are there, and also moisture is there. Okay, so this is the components that are present in cheese. So that's all about the cheese. Okay, yeah. And next is the ghee, right? So when butter, you all know how the ghee is made, right? So the butter, when you heat at high temperature, you know, the liquid part, the butter gets liquefied. Okay, so that liquid is what we mean by ghee. Usually whatever is there in butter, everything is there in ghee only, but only thing is the water and the milk solids are removed in the ghee. So you will have the fat content, you will have the protein content. Okay, so that high fat content is what observed in ghee. So that is all about ghee, guys. So we discussed about the composition of milk, composition of butter, composition of cheese, composition of cream, and composition of ghee, right? So now let us go for the next concept that is there in a chapter, which is very, very important. So how do you analyze fat content present in milk and butter? Okay, so we all know fat is present in milk and butter. Okay, so how do you know how much is the fat present? Okay, so here how do you know that how much fat is present? How much fat is present in milk and butter is what the concept, which is very, very important. So you can determine how much fat is there in milk and butter with the help of so many methods. But one of the important method is, Gerber method or Gerber method. Okay, so anything you can pronounce, Gerber method or Gerber method. So it is used to determine fat content in milk. Okay, so majorly in milk. So what do we do in Gerber method? Is we take an instrument called butyrometer. Okay, so remember this instrument name. What is the name of an instrument? Butyrometer. Okay, or butyrometer, whatever you want, you can pronounce it. Okay, so remember the instrument in the Gerber method, the instrument that is used is butyrometer. Okay, so we take the butyrometer. So inside the butyrometer, so butyrometer is an instrument something like this. I will show you the picture. So we will add the milk. We will add 11 ml of milk that we are supposed to find out how much fat content is there in it. So we'll add the milk. After we add the milk, then we add concentrated sulfuric acid. Okay, so add milk and then add concentrated sulfuric acid, and also we add an alcohol called amyl alcohol. Okay, so what are we adding? What is the procedure? Milk, we take the milk. Okay, so to milk, what are we adding? We are adding concentrated H2SO4, and we are also adding an alcohol called amyl alcohol. So when you add all of this to the milk, the fat gets separated. The fat gets separated. Okay, so concentrated sulfuric acid helps to separate the fat from milk. Very, very important. Okay, so we add all of this, and we will keep the butyrometer in centrifuge. Centrifuge is what instrument which spins the liquid. Okay, say, let me show you the figure for you all. Okay, yeah, see guys, this is the butyrometer. You can see this instrument, right? Say here this butyrometer is filled with milk. So here milk is there, along with milk concentrated sulfuric acid, along with that amyl alcohol is there. So all of this we will add and we will keep it in a centrifuge. Okay, so this is called as centrifuge. So this centrifuge rotates. Okay, rotates with very high speed. Okay, so that the fat content, so this liquid part, transparent yellow color liquid part is there, no, this is the fat. So fat gets separated and all the remaining solids, the protein or whatever is there in the milk, everything remains at the bottom. The fat content would be floating above, and from this you can measure how much amount of fat is there. Okay, so this is the whole story of Gerber method. Okay, so that is all about a Gerber method. Okay, so just remember what is the instrument name, butyrometer, and what and all the chemicals that we add. Sulfuric acid is added, amyl alcohol is added. After that we will centrifuge it and the fat content will get separated, and that's how we'll get to know how much fat is there in milk. Okay, so this is all about the analysis of fat content in milk and butter, right? Okay, so the next method is also there. The next method is Rose-Gottlieb method. So this Rose-Gottlieb method is used for testing fat in butter. So this is a method used for butter, guys. Okay, so what did we do here? Here also it is the same. We take milk and we add ammonia and alcohol here. So when you add ammonia and alcohol, the fat content gets separated and you can measure how much amount of fat is present in a butter. Okay, so just remember here ammonia and alcohol is added, there sulfuric acid and alcohol is added. Okay, yes, so that is the difference. So now, yes, analysis of fat is over, right? So analysis of fat in milk and butter is over. In milk it is a Gerber method. In butter it is a Rose-Gottlieb method. Okay, yes. So now coming to the analysis of minerals in milk and butter. Okay, so how do you analyze minerals? So what do you mean by minerals? I told you calcium, phosphorus, sodium, potassium, magnesium and zinc. So how do you find out how much of mineral content is present in milk? So it's very simple. So we use the method called ashing method. Okay, so what do we do in this ashing method? You know, analysis of minerals. So analysis means how much amount is present. That is what we are measuring. So how do you know how much amount of minerals is present? It is by ashing method. Analysis of minerals is done by ashing method here. Okay, so it is done by ashing method. So what do we do in ashing method? You know, we take milk and we will heat at very high temperature. We will heat at very high temperature. What will happen? All the mineral content, all the minerals will get converted into ash. Minerals are converted into what? Minerals are converted into ash, and we will take the weight of an ash and then identify how much is the mineral content is present. Okay, so all that protein, water content, fat content, everything would evaporate. Okay, but whatever the minerals that are present in milk, everything would end up in converting into ash. Okay, so that is why it is called as ashing method. See, look over here. What is the procedure? Say you are taking a milk and initially you are removing all the water content by evaporation. Then you are heating. You have to heat it at very high temperature, no? So that heating is done in a special furnace. Furnace means it is a heater. So it is done in a heater for about 4 to 6 hours. Okay, then the entire mineral content will get converted into a ash, and you are collecting that ash and you are dissolving that ash in HCl or this particular ash. You want to know how much is there, right? So you are again doing a chemical reaction to find out how much of ash is there. So that's why you are dissolving this ash in either HCl or HNO3, hydrochloric acid or nitric acid, to find out how much amount of mineral is there. Okay, so this procedure is called ashing method, guys. Okay, so you have another method, that is atomic absorption spectroscopy. So this is not necessary to remember, just remember the ashing method. So you have the third method here, inductively coupled plasma optical emission spectroscopy is there. So different methods are there to find out the minerals, but ashing method is much simpler. Okay, yes. So we understood how minerals are identified in milk, right? So analysis of mineral is over. Analysis of fat content we studied. And now how do you estimate water? Okay, how do you know how much amount of water is there in milk? You know, even in our villages, when milkmen gets milk, we test how much water is there, right? Do you know what instrument you call it as? Yes, it is lactometer. So analysis of water in milk. Analysis of water, okay, in milk. So what is the instrument you will use? You will use the instrument called lactometer here. So I will show you how actually the lactometer looks like. Okay, see here. So this is the lactometer. Okay, so you can see we dip, this is also a special instrument, something like this. Okay, so this is just dipped in a milk. So if it floats, if it actually floats, milk is quite pure. Okay, if it is not flowing nicely, then milk is impure. Okay, so that is the indication here. So actually speaking, milk is more denser, milk is more denser. Okay, density of milk is high, right? So when milk is more denser, when you introduce lactometer, your lactometer floats. Okay, so if water is mixed, okay, what will happen? Lactometer goes inside. Okay, so it goes, the more it goes inside, the more water is there. The more it floats, the more pure is the milk. Okay, so because you know the milk is more denser actually. So if I have to show you the procedure, right, so you can just read it here, okay. So adulteration of milk with water, that means mixing of water in milk, is a common malpractice that reduces its nutritional value and commercial worth, isn't it? So that's why it's very important to detect how much amount of water is there. So that is done by lactometer test. Okay, so guys, actually lactometer can show the reading also. If it is a normal milk, its specific gravity, specific gravity is nothing but density. So what are we measuring here? Density is what we are measuring. So in normal milk, the density is 1.028 to 1.032. Okay, so if water is mixed, the density gets reduced. Okay, so what will happen? The density is reduced. Guys. So the density, if the value is less than 1.028, if the lactometer reading shows less than 1.028, then the milk is mixed with water. Okay, so that is the indication. The normal milk should have the density this much to this much, but if the value is less than this number, then the milk is mixed with water. Okay, so that's how we can use lactometer test to detect how much water is present in milk. Okay, and you actually have formula also, percentage of water added can be calculated based on that. Okay, and this is one method. The other method is freezing point depression method. Okay, so just I'm mentioning the methods, but they are it's okay even if you don't study this method, but lactometer test at least try to remember. Okay, so this is all about analysis of water content in milk. So this is all about the dairy products. So what did we study? We studied the composition of milk, composition of butter, composition of ghee, composition of cream, composition of what else, cream. Okay, all of that, and later we identified how to find out the fat content in milk, right, mineral content in milk, and also water content in milk. Fat content, how do you identify? With the help of Gerber method. Mineral content, how do you identify? With the help of Ashing method. And water content, how do you identify? With the help of an instrument called lactometer. So the concepts of these aspects are very, very important for your exam. Hey everyone, in this section let us talk about beverages. So what are beverages? Beverages are those drinks which are taken as refreshments. Okay, so these drinks help us to rehydrate our body, right? So for example, we take fruit juices, coffee, tea, even alcoholic drinks like beer, whiskey, all of them come under beverages only. Okay, so beverages are those drinks which are taken as refreshments. Okay, so which are taken for rehydration of our body. So now there are two types of beverages. So as I told you, we have alcoholic beverages, okay, and we also have non-alcoholic beverages, non-alcoholic and alcoholic. So alcoholic beverages are the the beverages like beer, whiskey, okay, toddy, right? Toddy is that alcohol fermented drink that we get from palm trees. Okay, so that is called as toddy. So all these are alcoholic varieties. And now non-alcoholic beverages are coffee, tea, okay, so all those soft drinks and all of them come under non-alcoholic beverages. Now these beverages can be contaminated with some substances which are very, very toxic. Okay, so let us understand how to analyze those adulterants present in these beverages. Okay, and also let us analyze the identification of caffeine from coffee and tea. So usually the coffee and tea contains an alkaloid called caffeine. Okay, so let us now talk about some aspects on caffeine here. So what is a caffeine? Caffeine is a chemical that belongs to class of organic compound called alkaloids. Okay, so it belongs to class of organic compound called alkaloids, and it actually stimulates our central nervous system. Okay, so it stimulates central nervous system, isn't it? So whenever we feel sleepy, whenever we have to be alert, then we drink a cup of coffee or tea because it stimulates and activates central nervous system. So let us identify how much amount of caffeine that is present in a given sample of coffee or tea, because too much of caffeine should not be present and too less of caffeine also should not be present. Okay, so first let us analyze how to find out the concentration of caffeine in a given sample. So analysis of caffeine here, analysis of caffeine. Okay, so imagine if the sample is around 10 ml or 50 ml of a coffee and tea you already have with you, and if I ask you to find out how much of caffeine is there here, what is the concentration? Concentration means amount. Okay, so how much is the concentration of caffeine present in a given sample? Then you have a method with which you can identify, and the method is UV spectroscopic method. There are two methods, so let me show you the methods now. Okay, so you can see here, right, analysis of caffeine in coffee and tea is what we are going to discuss now. Okay, so if you look at the caffeine's chemistry, you can see the chemical name of caffeine is 1,3,7 trimethyl xanthine, and this is the molecular formula, molecular weight, all that is not necessary. So this is the chemical structure of caffeine. See, it is an organic compound. It is a very complex organic compound. Okay, so functional group is xanthine family. It belongs to xanthine family, and this caffeine, since it is organic, it will only dissolve in organic solvents like ethanol and chloroform. Okay, so that's why chloroform is usually used to extract caffeine. So where is the caffeine present? It is present in coffee beans and tea leaves, isn't it? So from tea leaves and coffee beans, we have to extract caffeine with the help of a solvent called chloroform. So first, if you want to find out how much caffeine is there, first you have to extract caffeine from tea leaves or coffee beans, isn't it, or a given sample. So how do we extract? So I am showing you the process in a very simple way. So caffeine can be analyzed by two methods, guys. One is UV visible spectrometry and the other one is by HPLC, which is nothing but high performance liquid chromatography. So both the methods try to remember, but I will explain UV visible spectrometric method, which is a standard method of analyzing the presence of caffeine. Okay, so this method I will be explaining for you all. Okay, so now UV visible spectroscopic method. What do we do first? First thing is we have to extract caffeine. So we have to extract caffeine, isn't it? So how do we extract? We take a coffee beans. We take some amount of coffee beans, or we can take tea leaves, isn't it? So let me show you the method of extraction here. Okay, so you have a method. Let me zoom it for you. Okay, so if you can remember this flowchart, it is more than enough, guys. So you take some amount of tea leaves or coffee beans or how much ever coffee or tea powder that you have, and you have to boil and filter. Okay, so you boil first and filter. Okay, take the filtrate. So take filtrate. Okay, so take that filtrate and add chloroform. Very, very important. To the filtrate, what are you adding? To the filtrate, you are adding chloroform. Remember this chemical? You are adding chloroform. So why are you adding chloroform? Because all the caffeine, the chemical caffeine dissolves in chloroform. Okay, so all the caffeine, whatever is there in this filtrate, no, everything gets dissolved in chloroform. Now again you are adding what? You are adding ethanol. Okay, so you are adding ethanol. So when you add ethanol, all the caffeine, okay, so all the caffeine is transferred into ethanol. So now the caffeine is there in ethanol. Okay, so redissolve in ethanol, I mean you are adding everything into the, you are transforming every caffeine molecule into the ethanol, and now you conduct for this caffeine which is dissolved in ethanol, you pass it through spectrometer. Let me explain what does the spectrometer do. So this spectrometer, it is an instrument where you have to keep the sample in this instrument. When you keep a sample in this instrument, this sample will absorb certain radiation. It will absorb certain radiation. So by knowing how much amount of radiation it has absorbed, you can identify the concentration of the caffeine. Okay, so here different samples of caffeine we will take and we will put it in the spectrometer. So it will give you the amount of radiation it has absorbed. Okay, so we in the spectrometer instrument is kept at 271 nanometer. Okay, so the spectrometer works at 271 nanometer. Okay, it will absorb certain radiations and you will get a graph. Spectrometer will also have a computer screen, so where you will have a graph of absorbance versus, okay, y-axis is absorbance value and in x-axis is a concentration value. So from this graph you will get a straight line, and from graph, okay, so from graph we can calculate concentration of caffeine present. Okay, in coffee. Okay, so don't worry, understand it in a simple way. So you are taking caffeine containing sample, okay, coffee beans or tea leaves, you are boiling and filtrating, you are collecting the filtrate, and to that you are adding chloroform. So purpose of adding chloroform is all the caffeine is going to the chloroform. Later you are adding ethanol, all the caffeine is going to the ethanol. Later this ethanol you are keeping it in an instrument called UV spectrometer. So UV spectrometer, the moment you keep it in UV spectrometer, based on the absorbance values, the solution will absorb certain radiations. So based on that you will get a graph. From the graph you can able to calculate the concentration of caffeine. Okay, so this is the method of identifying how much caffeine is present in coffee or tea. Okay, yes. So now, in coffee and tea, okay, instead of caffeine, chicory. Okay, so chicory, you must have heard, chicory is the adulterant. Okay, used in coffee and tea. Okay, so this chicory will have a taste of caffeine only. Okay, so some amount of chicory is definitely added. Okay, but if too much amount of chicory is added, then it is a dangerous. Okay, so just to cut the cost, coffee is very expensive. Okay, so that caffeine is very, very expensive. So that's why to reduce the cost of coffee or tea, they will mix it with chicory, which exactly looks like caffeine only. It exactly tastes like caffeine only. Okay, so if you want to know what is chicory, so chicory is actually a powder that we get it from a tree. Okay, see here. So what is chicory here? Detection of chicory in coffee. So this is the next concept here. So one of the most popular drinks in the world is coffee. However, chicory, a substance made from the roasted root of Chicorium intybus plant. Okay, you no need to mug up this scientific name. If you can, you can remember. Okay, so this is the scientific name of certain plant. So roasted root of that plant will exactly taste like caffeine only. Okay, so is frequently added to it to cut the cost or change its flavor. Okay, so that is about the chicory. But if too much chicory is added to coffee or tea, it is dangerous. Okay, so now how do you identify the chicory? So how do you detect the chicory presence in coffee? Okay, so it's very simple here. Okay, so it's very simple. You have a test for that. Okay, so you can do a chemical test called flotation method. Okay, so flotation method is a very simple method. Chicory is more denser than coffee. Okay, so density of chicory, chicory is more heavier than coffee. Okay, so here density of chicory is greater than density of caffeine, density of coffee. Okay, so it is more greater than coffee, right? So you take a coffee powder, right? So you put it in water. So this is the water. Take water in a beaker. So you add your coffee powder, whatever coffee powder that you want to test. Okay, so instead of coffee beans, they will mix it up with chicory. You want to test whether how much amount of chicory is present. Okay, so you just add it to water. Okay, since chicory is more denser than coffee, what would you observe? The chicory will go down and settle because it is more denser. So the one which is going down is a chicory. Okay, the one which stays up, coffee is less denser, right? The one which stays up is a coffee. Okay, so coffee, if it is a pure coffee powder, it stays. Okay, so the powder stays on top. So whatever the particles that went down and settled at the bottom of a beaker in water, then all of that is chicory. So this is how, just based on the density difference, you can identify whether something is a coffee or chicory. So that is a flotation method, guys. Okay, so now you can have another method here, that is tincture of iodine test method. So very simple, we all know that, okay, iodine when it is added to starch, okay, you will observe blue green color, okay, blue green color or bluish violet color, isn't it? So we all know this is an iodine test. So whenever iodine is added to starch, you will observe that blue green color, okay. So if you want to test the presence of iodine, you just add starch to that, okay, add starch to that. If you get bluish color or violet color, presence of iodine is confirmed. You know what, chicory contains starch, okay, so the chicory contains some amount of carbohydrate, right? So what does the chicory contains? Chicory contains starch. Okay, coffee does not contain starch, but chicory contains starch. If it is a chicory, because it contains starch, on adding iodine, you will observe that blue color or violet color. Okay, so this is a chemical test which is called iodine test. So with the help of iodine also, you can test whether a substance is chicory or coffee. Coffee will not give any blue color, okay, because it does not contain any starch. Chicory will give blue color on reacting with iodine because it contains starch. Okay, so two methods to identify the presence of chicory. Number one is a flotation method, density based. Number two is a iodine method. These are the two methods you can remember. Next in the syllabus we have, okay, so we have to determine an adulterant, you know, in toddy. So I told you toddy is a fermented alcoholic drink that you get from palm trees. Okay, so detection of chloral hydrate in toddy. Okay, so this chloral hydrate, okay, it is a chemical used as adulterant, okay, in toddy. Okay, toddy is a alcoholic drink which you get it from palm tree. Okay, so this chloral hydrate is there, no, it's very poisonous and it is sedative. It increases sedative and toxic effects of toddy. Okay, sedative property it has got, okay, hypnotic property it has got, very dangerous chemical, that is chloral hydrate. So people will add this chemical purposefully to toddy to make it more powerful, okay, to make toddy more sedative and toxic. Okay, so now how do you identify the presence of chloral hydrate in toddy? So you can do one chemical test here. Okay, so let me show you the chemical test. Okay, so the chemical test is called screening test or Fujiwara test. So remember the name of a chemical test, that is Fujiwara. Okay, so it is called as Fujiwara test here. Okay, so just Fujiwara test. So what do we do it in Fujiwara test, guys? So you no need to read all of this. So just remember, see, look at this diagram. All the method is explained in these two sentences here. So what is Fujiwara test? You are taking a toddy sample. So toddy sample, if it has got chloral hydrate chemical, then what do you get? You will get red or pink color. Okay, on adding what to this toddy? When you add pyridine, along with that sodium hydroxide, NaOH in the sense sodium hydroxide, okay, and you add these two chemicals and hit it, if you get pink or red color, then chloral hydrate is present. Okay, so if you don't get pink or red color, then that chloral hydrate is not present. Okay, so remember this test, that is Fujiwara test. Okay, so what do you add to the toddy? You are adding two chemicals here. One is pyridine, the other one is NaOH. Nicely you are heating. So on heating, if you observe pink or red color, then the adulterant chloral hydrate is present. Okay, if pink or red color is not observed, then chloral hydrate is not present. And this chloral hydrate is very, very dangerous. It will act as a sedative. Remember, it should not be there in toddy. Okay, yes. So that is all about the adulterant analysis in toddy. So now in ethanol, in normal alcoholic drink, there can be a mix of methanol. Okay, there can be a mix of methanol. So how do you identify the presence of methanol? You know, in any alcoholic drink, if methanol is mixed, this is very dangerous. It can even lead to death. Okay, so it can lead to blindness also. So starting stage is blindness, the final stage is death. So alcoholic drinks should not be mixed with methanol. So now the question is, how do you identify the presence of methanol? So here is the test for that. Okay, so Fuzwana test is to identify chloral hydrate in toddy. So now let us go for the method that is used to identify methanol. Okay, yeah, estimation of methanol or methyl alcohol in alcoholic beverages. So methanol is also known as wood alcohol, highly toxic to humans. Okay, it may be unintentionally present in alcoholic beverages due to fault fermentation or illegal distillation process. Even small amounts of methanol can cause blindness, organ failure or death. Okay, so that's why it's very important to analyze methanol. Okay, so how do we analyze methanol? How do we know the presence of methanol is? Just remember this, guys. Okay, so remember this. Okay, so you have a test called chromotropic acid test or colorimetric test. Okay, so chromotropic acid test. Remember the test name, chromotropic acid test. What do we do? Methanol, methanol gets converted into formaldehyde. Okay, so usually methanol, when it is kept for a longer time, you know, here your methanol is there, no, that will automatically gets converted into formaldehyde. This formaldehyde is very dangerous. Okay, so when methanol is kept for a longer time open to the atmosphere, it gets converted into formaldehyde. Now to that formaldehyde add what chemicals? Add sulfuric acid and also add chromotropic acid. So what are you adding? Chromotropic acid. So after you add all the chemicals, if you observe violet color, then methanol is present. If you don't observe violet color, then methanol can be absent. Okay, so this is the test that you will do for the presence of methanol. Okay, so that's all about, you know, the darker the violet color, the more and more darker violet shade if you observe, then the higher the methanol concentration that you can observe in a sample. Okay, so again here concentration can be identified with the help of instrument called calorimeter. Okay, so calorimeter is the instrument which is used to identify the level of concentration. Whether, okay, if too much is there, then how much? Okay, if you want some number, it can be identified with the help of an instrument called calorimeter. Okay, so this is all about identification of methanol. So in case of beverages, we studied the 4 concepts. Okay, study 4 concepts. One is, how do you find the concentration of caffeine in coffee and tea? That is using UV spectrometer. Okay, instrument called UV spectrometer. Okay, all that process try to understand briefly. So second concept that we studied is chicory identification in coffee. Okay, chicory is the adulterant which just mimics like coffee only. It tastes like coffee, it gives rich color and etc. So two methods you studied there, flotation method as well as iodine method. Okay, so two methods. And third one is identification of chloral hydrate in toddy. Okay, and fourth one, identification of methanol in alcoholic drinks. So these are the four identification methods. Briefly try to remember the process and the chemicals that we use in the process. Okay, so that is all about beverages.